it's x squared, so you know I can't do substitution. Okay, but I can do this actually a little bit. So it's just a trick actually, that if I, for example, add and subtract 1 minus x squared, I put a plus here, so it's going to be negative x squared. So add 1 and subtract 1 divided by square root of 1 minus x squared and dx. So this is going to be x squared sine x plus, I can simplify this as 1 minus x squared over square root of 1 minus x squared minus 1 over square root of 1 minus x squared and dx. Okay? This will become x squared sine inverse x plus, I can simplify this to be square root of 1 minus x squared minus, what is the function whose derivative is 1 over 1 minus x squared? Square root of, so it's sine inverse x, so its antiderivative is really going to be sine inverse x plus constant. So the outcome is x squared sine inverse of x minus sine inverse of x plus this integral 1 minus x squared dx plus constant c. We will learn in our next class that how to solve such integrals. So I'm keeping it as it is for our upcoming discussion. Okay? So this would be really the integral of this. So if you have sine inverse x multiplied with some function x, then you have to do the trick in this manner. Okay? What if I just have sine inverse x and I want to find its integral? The answer is still integration by parts would help you, because you can write this as 1 multiplied by sine inverse of x dx, and you can do what you did here, that take f of x to be sine inverse x and g prime of x to be 1. So the f prime of x will become, and things will be much better in this case. So it's going to be 1 over square root of 1 minus x squared, and g of x, the integral of x is going to be 1 actually. So the other side of the integral, in other words, the integral of sine inverse of x dx is going to be f of x multiplied by g of x, in other words x sine inverse x minus f prime of x, which is 1 over square root of 1 minus x squared times g of x dx, in other words x dx. Now this is a pretty easy situation actually, because I can solve this integral. So how you can solve this integral? For example, let's compute, let's call this, for example, equation number 1, and let's solve this integral separately. So let's say t is 1 minus x squared. Then dt is going to be negative 2x. Okay? Dx. This is what it is going to be. You can say. So what should I do? So in this integral, in other words, this integral, okay, x over square root of 1 minus x squared dx, if I multiply by negative 2 and divide by negative 2, things will be okay. So this will become negative 1/2 dt divided by the square root of t. Then you know how to solve this integral. Negative 1/2 integrating t power negative 1/2 dt. Then you can say this will become t power 1/2 t power 1/2 divided by 1/2 multiplied by negative 1/2. This 1/2 will cancel out with this 1/2, and you're going to have negative t is square root of 1 minus x squared. So in other words, we computed this integral, and it turns out to be negative 1 minus square root of x squared. So hence, the integral of the sine inverse x dx is going to be x sine inverse x, and minus multiplied by this minus is going to be plus square root of 1 minus x squared plus constant c. So you have it actually. Okay. So you have this result. You're going to have the same kind of trouble if you're going to compute, for example, the integral of x log x or log x, because if I take this to be f of x and this to be, say g prime of x, then the trouble would be, what is the integral of log x actually? In other words, what is a function to which if I differentiate, the result would be log x? So this would be difficult to guess. So the best is, okay, to choose this as f of x and this as g prime of x. So let's do this, for example, first for simple log x. Simple log x. So something that is difficult to integrate, take it as g prime of x. So what should I do? So here I can take, for example, f of x to be 1, no, f of x to be log x and g prime of x to be 1 actually. So the f prime of x is going to be 1 over x, and g prime of x is g of x is going to be x. So if you substitute the values log x dx, the formula says f of x multiplied by gx, so it's going to be x log x minus f prime of x is 1 over x times g of x is x dx. X will get cancelled and you're going to get 1, and if you integrate 1, the integral of log x is x log x minus x actually. No one can guess actually this, integral, this as the antiderivative of log x actually. It's really difficult. Okay, it would be fun to think about what will happen if you have x log x here. Okay, then obviously you can also see that this is not going to be difficult. Why? Because then g prime of x is going to be 1, and this is going to be x square upon 2. So here you're going to put x square upon 2 multiplied by 1 over x. So you're going to get x here, and you can integrate it easily. So even with the x log x, it's not difficult to integrate. So these are some of the exercises that you have to do for yourself. Now, I would like to talk about an interesting type of integral, and that interesting type of integral is really interesting actually. What if you have e to the x and sine x dx, okay, both of, so it does not involve the algebraic function, it involves e to the x and sine x. The question is, what should we do then? Okay, what should we do then? So in that case, what you can do, you can I mean, I would say that you should keep yourself always open for any choice. Take this to be, for example, f of x, and this to be g prime of x, and see what happens. Take this to be, f of x, and take this to be g prime of x, and see what happens. Are you able to simplify the integral? Are you able to solve the problem actually? Okay, so make yourself. So if you have exponential multiplied by a trigonometric function, sine x and cos x, I'm only talking about trigonometric function sine x and cos x, not about tangent x or some other functions. So it's about, the discussion is about sine x, cos x actually. Then the best is that if you take f of x to be e to the x and take g prime of x to be sine x actually. Okay? You will see a miracle. So what would be f prime of x? And I invite you to think otherwise actually. Okay, so the integral of sine x dx is going to be negative cosine x dx. So with this, what are you going to get? So f of x, g prime of x, e to the x sine x dx is equal to f of x gx e to the x negative cosine x plus minus, what are you going to get? F prime of x, which is e to the x, and g prime of, f of x is e to the x, it's going to be f prime of x e to the x, and g of x is going to be negative cosine x and dx. Okay? Am I doing something silly? I need to put a g prime of x. No. What was the formula? So the formula goes like f prime g dx equal to fg minus fg prime dx. Okay? If you have fg prime, you're going to have f prime g. And now I can make substitution. E to the x sine x dx equal to fg e to the x negative cos x minus f prime is e to the x sine x and dx. So if you simplify this, e to the x sine x dx, you're going to get something interesting. E to the x cosine of x minus, again the same function repeated actually. Again the same function repeated. So the trick to give such problem is that give this integral a name I. So give such integral in which none of the function is reducing actually. Okay? Sin x will become cos, cos will become sine, e to the x will become e to the x, so none of them is simplifying. So if I give this function a name I, then how does this equation will look like? I equal to minus e to the x cos x minus I. This is what that you're going to get actually. And we are interested in finding the value of I actually. So I can take this I, sand this on this side, so you're going to get I plus I negative e to the cosine of x plus say constant c. So this will become 2I e to the x cosine x plus constant c. So the I will become minus 1/2 of e to the x cosine x plus c. You have to also divide it by constant by 2, but you can again give it the name c actually, because this constant is arbitrary, doesn't matter. Okay? So you got this value of I, and I is really e to the x sin x. Okay? So if you have this kind of integral, you can play this trick actually. Okay? This trick would also work when you have e to the x multiplied by cos x. Okay, e to the x multiplied by cos x. The trick would work. Give it a name I. Give this f and g prime. Simplify. You will see that this integral will appear another time here actually. So what you can do, take this on the other side, add them, divide by 2 and you get your answer. Okay. Now I would like to do a last thing. By the way, what if you have a to b and f prime of x, f of x, g prime of x dx, what would be the integral? The integral is going to be simple. Take f of x, g of x, substitute a to b minus the integral from a to b, f prime of x, g of x dx. So everywhere you just have to put the limits in. Okay. So here you're going to put the limit a to b. So b, f of b, g of b minus f of a, g of a minus this function. So the trick is going to be precisely really the same actually. Okay. Based on this, try to calculate the tangent inverse x and dx. Okay. So it's again inverse trigonometric function, so the same trick would work. So I'm not getting into what do you call the details of it, but it's not difficult to calculate. That you take f of x to be tan inverse x and g of x to be 1, g prime of x to be 1. Okay. Then f prime of x is going to be what? 1 over 1 plus x squared, g of x is going to be x. And then you substitute, if you substitute the values into the formula, you're going to get f of x, g of x. So x tangent inverse x from 0 to 1 minus 0 to 1. F prime of x is 1 over 1 plus x square and g of x is x. So it's going to be x over 1 plus x square and dx. Okay. I'm leaving this integral for you to calculate because this is easy. The derivative of 1 plus x square is present above. Okay, so it's x. Calculate it for yourself. And this is also not easy to calculate. So if you substitute 1, so you're going to get tan inverse of 1 minus, when you're going to substitute 0, this will be 0 multiplied by the tangent inverse of 0, but since 0 isn't multiplied, so this will be 0. Okay? And you can calculate this integral, and you can see actually that this, when you will calculate this integral, it will become log of 2 by 2. So the net answer will become, what is the angle that of the tangent that gives you 1 actually? So we know it's pi by 4. So the net answer is pi by 4 minus log 2 over 2. Okay, so you have to just neatly apply this technique actually. Or simply, if you want to find a definite integral, solve that integral first. Whatever answer comes, put the limits. Simple. Forget about limits first. Solve the integrals, calculate the answer, and then whatever answer comes, just substitute the limits. Okay. Now I would like to solve, maybe end my discussion at a reduction formula. So, say I want to compute sine power nx dx actually. This is what that I would like to compute. Okay. So this is reduction formula. There are other reduction formulas as well. They are in exercises. So I'm driving one, so you have to drive the other side. So I want to calculate sine nx dx. Okay. So how can I do it? For the sake of simplicity, let me give it a name in. So if there is a power n on it, I am giving it the integral of sine power n dx a name in. So if this will be 3, I'll put a 3 here. If this will be 4, I'll put a 4 here. Okay, that's what it is. So what we can do, for example, here. So I want to apply the integration by parts, so I can do this. Let's do sine n minus 1 x sine x dx. This is really in. I haven't changed anything, just made the product actually. And take, say, f of x to be sine n minus 1 x, okay, and g prime of x to be sine x. So the f prime of x is going to be what? N minus 1 power sine n minus 2x multiplied by the derivative of the sine x, which is going to be cosine x. And what would be g of x? So we need to integrate sine x dx. So it's going to be negative cosine x. So this is what is going to be my g of x. So what should I do? Let's substitute the values. So in is f of x multiplied by g prime of x, in other words, sine n power x dx equal to what? Equal to f of x gx, in other words, sine n minus 1 x times g of x is negative cos x, so it's going to be negative cosine x minus what you're going to get here. So you're going to get sine f of x is a sine n minus 1 x, but you have to put the f prime of x, so it's going to be n minus 1, okay, n minus 1 sine n minus 2x times cosine of x, okay, cosine of x multiplied by g of x, so it's negative cosine of x actually dx. This is what that you're going to get. Okay. So if you simplify it a bit more, sine n minus 1 x cosine x. So this is a number, you can pull it out. Minus will become plus, for example, n minus 1 sine n minus 2 x, and cosine x will become cosine square x and dx. So what should I do next? I can do something interesting. In the place of cosine square x, I can replace 1 minus sine square and see what you get. Sine n minus x cosine x n minus 1 sine n minus 2 times 1 minus sine square x and dx. So if you simplify this a bit more, sine x n minus 1x cosine x n minus 1. So if you multiply this integral of sine n minus 2 x dx, this will become minus plus n minus 1, okay, n minus 1, yes, n minus 1 cosine is 1 minus sine square. Are we doing some mistake? Okay. So this minus will be multiplied with this minus and this will become plus actually. So this will become plus, this will become plus, and this will become minus. And you're going to get I sine n power x dx. Now I would like to rewrite this expression. So here I have in. So this in is equal to minus sine power n minus 1 x cosine of x. Okay. Now what is this? So if in is sine power n x dx, what would be sine power n minus 2x? I can call this I n minus 2. I n minus 2. And what is this? This is again the same expression in. So I can say this is n minus 1 in. Okay, n minus 1 in. So what we will like to do, we will like to find the value of in. So what we should do, so we can take this on the other side. We can take this on other side. And we can solve it actually. So if you take this on the other side, maybe if you wish you can add a plus constant. If you add this on the other side, so you're going to get in plus n minus 1 in plus n minus 1 in equal to minus sine n minus 1 x cosine x plus, okay, plus n minus 1 n minus 1 n minus 2 n minus 2. And if you simplify this, so if you take for example in common or multiply in with both, so you're going to get in minus, so this will become minus in n in. So in will get cancelled out and you're going to get n actually. So if you simplify this, this will become n in. Hence in will become what? Minus 1 over n sine n minus 1 x cosine of x plus n minus 1 over n and n minus 2. Now this is really, what do you call, a miraculous formula. It will make your life way easier if you want to do the computations actually. So let me show one example with you and end the discussions, today's discussion. So imagine you want to compute sine power 4x dx. So this is like your I4. Okay? You know the formula for in actually. So the I4 is going to be negative 1 over 4 sine n minus 1 x is sine cube x cosine x plus n minus 1 upon n, so it's going to be 3 upon 4 in minus 2, so I2 actually. Now I can also again calculate the value of I2 from here. It's not difficult. Minus 1 over 4 sine cube x sine x plus 3 upon 4. So how can I calculate the value of I2? So the I2 will become minus 1 over 2 minus 1 over 2 sine n minus 1, in other words sine x cos x, and plus 2 minus 1 upon 2, so it's going to be 1 upon 2 and I0. Okay, I0. Now what is I0? So here is the I0. So by I0 I mean integral of sine power 0 x dx. Okay? Now what is sine power 0? So it's going to be 1. So this integral is going to be x actually. So this integral is really x plus constant. So just